Okay, kiddo, here you go. Trigonometry and special right triangles. All right, you need to know SOHCAHTOA and what it means. All right, these are the buttons on your calculator. Sine, cosine, and tangent. The O, the H, and the A are the sides of a triangle. All right, so sine of an angle is equal to opposite over hypotenuse. The cosine of an angle is equal to adjacent over hypotenuse. And the tangent of an angle is equal to opposite over adjacent. So when you're doing this, the second letter is the numerator, the third letter is the denominator, okay, and so on. Numerator, denominator, numerator, denominator. All right, I would suggest labeling the sides of your triangle. Okay, so this is the angle that you're working with. I always tell my kids label the hypotenuse first. That's always across from the right angle. Then you have your opposite, the side that's opposite the angle that you're given. And then you have your adjacent. Okay, circle what you want to find. Circle what you know. Okay, you just circled the H and the A. The H and the A go together in cosine. So you're going to have the cosine of your angle, and your angle is 32 degrees. Cosine is adjacent over hypotenuse. So it's going to be 7 over x. All right, your goal is to solve for x. We need to get x by itself. So what we're going to have to do is we're going to have to multiply by x. Set those x cancel. And on the left-hand side, we have just the 7. On the left-hand side, we have x times the cosine of 32 degrees. Now our goal is to solve for the x. That says x times the cosine of 32. So to get rid of that, you're going to have to divide by the cosine of 32 degrees. All right, my suggestion, put this in the calculator exactly as you see it. Type it in as a fraction, 7 over the cosine of 32. Now you told me that your calculator is already in degrees. Just always make sure mine is. So I'm going to do my fraction button, 7 over the cosine of 32. And then round whatever he wants you to round to. In my case, I guess I'll round to the nearest tenth, so 8.3. It's on highlighter. So 8.3. Okay, that's rounding to the nearest tenth. All right, question number 2. All right, so what do we have? This is my angle, so I label my hypotenuse, my opposite, my adjacent. This is what, this case I want to find an angle. So instead of circling what I want to find and what I know 2 things. I know this side and I know that side. Look at what I circled, the O and the H. The O and the H go together with sine. So we're going to have the sine, and next to the word is always your angle. In this case, my angle is x, equals opposite over hypotenuse. Now, when you're trying to find an angle, you're going to hit, you want the inverse. So I'm going to hit second sine. Whoop, I have other stuff there. Second sine. So it looks like this. And then just type in your fraction, 12 over 15, and that will give you the value of your angle. So fraction 12 over 15, and again, round whatever he wants you to round to. I'll round to the nearest degree. So I get 53 degrees. Okay. All right, question number 3. Here's my angle. So I have my opposite. I'm sorry, that's a mistake. That's my hypotenuse. I have my opposite. I have my adjacent. This is what I want to find. This is what I know. So that's the O and the A. The O and the A go with tangent. Sorry if I'm making you dizzy. So I have the tangent. Next to the word is always your angle. My angle is 46 degrees. Opposite over adjacent. So 9 over x. Okay. I want to solve for x. So I need to get it by itself. So I have x times the tangent of 46 degrees is equal to 9. I want to solve for x. So I'm going to divide by the tangent of 46 degrees. put that into your calculator the way you see it. Fraction 9 over the tangent of 46 degrees. And then again, around accordingly. I'll do the nearest hundredth this time, and I get 8.69. Okay. All right, question number 4. All right, so this is my angle, this is my hypotenuse, this is my opposite, this is my adjacent. When I'm finding an angle, I have to circle 2 sides. I know this side, I know that side. That's the O and the A. The O and the A go together with tangent. Okay, so I'm going to have the tangent of my angle equals opposite over adjacent. When you're finding an angle, that's when you use that inverse button. Okay, that second button. So I'm going to do second tangent and then 5 over 9. And round accordingly. So I'll go to the nearest degree. So 29 degrees. All right. Let me do another one that you haven't seen yet that I didn't draw for you. Okay. Let's say that I have, whoop, I'm going to sneeze. Excuse me. Let's say that this angle here is 62 degrees. All right, and let's say that this is 6 and this is 10. Whoop, let's say I want to find this actually. Okay, so this is my angle. So this is my hypotenuse, my opposite, my adjacent. Okay, the O and the A. So tangent, next to the word is always your angle, opposite over adjacent. I want to solve for x. And multiply by 6. Now you have 6. Tangent of 62 degrees is equal to x. Now on this one, notice that the x is all by itself. So you're just going to type that into the calculator exactly as you see it. 6, tangent, 62. And then again, round accordingly. So let's round to the nearest thousandth this time. 11.284. Okay, so that's kind of trigonometry. Now, if he gives you all 3, let's say he were to give you all 3 sides. Let's say he tells you this is 3, this is 4, and this is 5. And let's say he asks you to find these 2 angles. Okay. You want, let's say, to find this angle first. Okay. Hypotenuse, opposite, adjacent. You have all 3 sides. When you're using trigonometry, right, look at these, you can only use 2 sides. So when you have all 3, you have a choice, all right? Pick any 2 sides. Let's say pick this one and this one, okay? Could you use the 3? Yes, because you know it. But just pick 2, circle them, and decide what you have. If those are the 2 sides I'm using, I have the h and the a. And the h and the a go together with cosine. So I have the cosine of x is equal to adjacent over hypotenuse. So I'm finding an angle, so that's my inverse button. And then again, just second cosine, and then 4 over 5. And I would get, depending on what you round to, let's say the nearest degree, 37 degrees. Now, if you also needed to find y, that angle there, you could set up another trig ratio, or the 3 angles of a triangle always add to 180 degrees. So if you know you have a right triangle, that's 90 degrees. We just found that angle is 37 degrees. We could just add up the 2 angles we know and subtract from 180. All right, so that's an option. So 90 plus 37 is 127. Subtract 127 from 180 is 53 degrees. So once you know what the right angle and another angle, you could find the third angle by adding up and subtracting from 180. All right, now special right triangles. Okay, special right triangles, there's only 2 types, where the angles are 30 degrees, 60 degrees, and 90 degrees, or 45 degrees, 45 degrees, 90 degrees. Now, in a 30, 60, 90 degree triangle, the ratio of the sides are always 1, okay? Then I do the hypotenuse next, 2 and radical 3. So we say 1 to radical 3 to 2. So what that means is, let's say I tell you that that's 30 degrees. If this is a triangle, right, the 3 angles have to add up to 180, so this angle would have to be 60. So if I give you one of the angles, let's say I tell you that, if I give you one of the sides, let's say that this side here is 20. That's the side across from the 30 degree angle. That's going to be the shortest side of my triangle. The hypotenuse is always twice that. So the hypotenuse would have to be 40. And then the side that's across from the 60 degree angle is your shortest side times radical 3. So it'd be 20 radical 3. Okay. In a 45, 45, 90 degree right triangle, the sides are in the ratio of 1 to 1 to radical 2. And the reason it's 1 to 1 is because if you have 2 equal angles, it's isosceles. So you're going to have 2 equal sides. So if this is my triangle, and I tell you that that angle is 45, this angle has to be 45. So if you have 2 equal angles, you have 2 equal sides. Those sides have to be equal to each other. So if I tell you that this side is 10, this side would be 10. And this hypotenuse would be 10 radical 2. Okay. Now let's say, let me switch up let's say that's 30 and that's 60. And let's say I tell you that this side here is 6 radical 3, and I ask you to find the other 2 sides. Well, my ratios are 1, 2, radical 3. I gave you the side across from the 60 degree angle is 6 radical 3. So to find the side across from the 30 degree angle, I just divide by the radical 3 and I get 6. And then to find the hypotenuse, I just take my shortest side and multiply by 2. So I'm going to get 12. All right, now, if I did this, let's say I tell you that that's 30, which makes that 60. And let's say I told you that this hypotenuse were 8. Actually, let me do this. Let me tell you that the side across from the 60 degree angle is 8. Okay, so 30, 60, 90, 1, 2, radical 3. Now look what I gave you here. I gave you the side across from the 60 degree angle. That's 8. Which means to find the shortest side, the side across from the 30 degree angle, look what we did here. We divided by radical 3. So to find the shortest side, just divide by radical 3. So I did 8 over radical 3. And then to find the hypotenuse, I just multiply by 2. So 8 over radical 3 times 2 is equal to 16 over radical 3. All right, something tells me he could give you something like that. All right, and then if I go back to the 45, 45, 90, let me just give you something a little bit different. Let me tell you, let's say I tell you that this side here is 11 radical 2. And I ask you to find the other 2 sides. And I tell you it is isosceles, right? 45, 45, 90. So the ratio is 1 to 1 to radical 2. So if I give you one of the sides is 11 radical 2, that means the other side is 11 radical 2. And if I have to find the hypotenuse, I'm just multiplying by radical 2, right? Multiply by radical 2. So I take 11 radical 2, multiply radical 2, and I get 11 radical 4. But the square root of 4 is equal to 2. So I get 11 times 2 is equal to 22. So I get 11 radical 2, and I get 22. All right, I'm going to go back and do those other 2 examples, but that was just a kind of couple other things he could give you. All right, so let me write my ratios. And these you need to know. So if this is 90, and I have 30, this must be 60. What did I give you? I gave you the hypotenuse. The hypotenuse is 5 radical 3. So if I'm working backwards and I want to find the shortest side, the shortest side is always half the hypotenuse. So I would just do 5 radical 3 divided by 2. And then to find the side, so that just gave me the side across from the 30-degree angle. The side across from the 60-degree angle, I just take my shortest side and multiply by radical 3. So 5 radical 3 over 2 times radical 3. And I don't know if he's going to give you something this hard, but I want you to be prepared. So when I multiply those, I get 5 radical 9 over 2. Well, radical 9 is equal to 3, so I get 5 times 3 over 2, or 15 over 2. If you prefer to write it as 7.5, that's fine. Okay. All right, now this one over here. It's a 45, 45, 90-degree triangle. Ratio is 1 to 1 to radical 2. What did I give you? I gave you one of the sides, which means that my other side is 7, and it means my hypotenuse is 7 radical 2. So x would be 7, y would be 7 radical 2. And over here, what would we have? X would be equal to 5 radical 3 over 2, and y would be equal to, what's y equal to? Y would be equal to 15 over 2. Okay. All right, so hopefully that helps. Watch this a couple times. Let me know if you need any help with anything. I love you.